Good afternoon, students. Myself Sushmita, Assistant Professor, Department of Electronics and Communication Engineering. So, in this session, we will be learning about pattern multiplication in antennas. So, on completing this particular session, you will be able to define what is pattern multiplication and also what is pattern multiplication method, and you will be able to draw the diagram for element linear array. So pattern multiplication is a very useful method in the design of arrays, that is antenna arrays. Why in the sense it will be making it easy possible to draw the patterns of complicated arrays rapidly, mostly by inspection. So in order to illustrate this method, we are going to consider 4-element array of EQ spaced identical element antennas, and we are going to keep the spacing between the two units BD, that is lambda by 2. Now we are going to assume that all the elements are supplied with equal magnitude and currents which are said to be in phase. Now this is the structure of 4-element linear array. So we are having 4 arrays ranging from R1, R2, R3 and R4, and they are placed at equidistance called angle 5, and the cos angle between them is taken as d cos. So as the point P is called as the resultant field which is obtained from and far away, so we are going to assume that the radiation from antenna is obtained in the form of parallel lines. So the radiation patterns that is obtained from antenna 1 and 2 will be treated as a single pattern that is obtained in the output, and similarly the radiation pattern of the antenna from 3 and 4, which are spaced distance apart, but since they are fed with equal current that are in phase, they are also going to be treated to be operated as a single unit again. So now we are going to consider, instead of considering two separate elements 1 and 2, we are going to replace it by a single antenna by locating at a midpoint away between them. So similarly we are going to replace antennas 3 and 4 by single antenna having a same pattern. Now both the antennas have bidirectional pattern, that is figure 8 pattern space distance apart from each other, and they are fed with equal currents in phase. Now the resultant radiation pattern of 4-element array can be obtained by pattern multiplication of patterns. So we are going to note this multiplication as polar graphical multiplication for different graph values. You can see in the radiation diagram that is mentioned in the PPT. So this is a single identical pattern which has a radiation in all 4 sides, and this is another radiation pattern which has a radiation in the 2 sides, that is top and bottom. And now we can see pattern multiplication method. Radiation pattern of 2 antennas are placed with lambda by 2, and it will be placed at a distance with a lambda discharge. So you can see there is a lobe, equal distance lobe, as we saw in the previous slide. It is going to get multiplied and the antenna is going to be placed at a distance of lambda by 2. So this is how we are going to get the radiation pattern at the output. So now let's see the principle behind this. So this principle pattern is applicable in 2 or 3 dimensional patterns. So we are going to express this particular radiation pattern in the sense of 3-dimensional. So that is E is equal to total field. Now we are going to calculate individual score, isotropic point sources, and again individual source for phase pattern as well as isotropic point source for phase pattern. So these are indicated by few mathematical expression as EI of theta comma phi for field pattern of individual source, and field pattern of array is given as EA of theta comma phi. So this is how they are denoted. So now let's see the advantages of array multiplication. The first point is width of the principal lobe, that is the main lobe. The width between the nulls and the corresponding width of the array pattern will be always same. So second advantage is the secondary lobes are determined from the number of nulls resultant pattern. So third point, the total field pattern on a non-isotropic but similar source can be symbolically written as E is equal to EI theta comma 5 into EA of theta comma 5, which is again cross product of E pi of theta comma 5 plus EPA of theta comma 5. This is multiplication of field pattern and addition of phase pattern. So now we will see some quiz question based upon pattern multiplication. So first question is, pattern multiplication is the multiplication of single array radiation pattern dash. Okay, so I hope you will be able to answer this question. Thank you for watching this session. If you have any doubts, do post it in comment. Thank you.